Here's a recap of what we were doing last week before we broke for the weekend, and then the snow day, and then the drop, and then Ash Wednesday's Mass. So we haven't met in a week about, so let's go over what we talked about before we left last week. One of the things we talked about was generating all of our trig functions in terms of x, y, and r versus our opposite, hypotenuse, and adjacent. So these are some things we kind of have to memorize. So y over r is sine, x over r is cosine, and then y over x is tangent. And then we're also reciprocal functions, cosecant theta, secant theta, and cotangent theta. And those are just the reciprocals of that. Our first three, r over x, and then x over y. So we need to remember these as we go through our problem. So I'm giving you that the point 4, -5 is on the terminal side of an angle, and it's in standard position. And we're going to state the values of the 6 trig functions. So if you want to, you can stop the video now and go check it out. But I'm going to start right now. So I'm going to plot the point, x and y, for -5, somewhere here. And I'm on the terminal side of an angle. So I'm not quite sure if the angle goes this way, or if the angle was going this way. I'm not 100% sure, but I do know that this point lies on the terminal side of the angle. And what we must remember is when we're doing that and we draw it in, we need a reference triangle. And our reference triangle is always going from the terminal side to the closest x-axis. And that angle right here, our theta, our reference angle, is going to have the same trig values as this bigger one here, or as well if the angle was a negative angle going that way. So if we place some values on here, our x is 4 and our y is -5. So the only thing we're missing is we're missing this radius or the length here. So that's kind of one of our first steps, is to set up the Pythagorean theorem and figure out what the length of the hypotenuse is, or the length of the radius in this case. So we have 4 squared plus -5 squared is the radius squared. 16 plus 25 equals r squared. 41 equal to r squared. So r is equal to the square root of 41. And we're always going to have that be positive. So let's set that over here, square root of 41. Now that we know x, y, and r, we can find any ratio that it's asking us for. So 4, -5, and then square root of 41. So let's say we're trying to find all 6. The sine of theta, we're going to have y over r. We can't leave it like that, so we need to do some simplifying. And remember, to simplify radicals, to rationalize them, you're just multiplying the numerator and denominator by radical 41, and that ends up canceling out in the denominator. So that is going to happen for sine. It's also going to happen for cosine over square root of 41. 4 radical 41 over 41. And then the tangent theta, oh, I forgot this other one, is y. So we have -5 over 4, and that one's fine. If we go here for our reciprocals, the cosecant of theta is r, that's our square root of 41 over y, -5. The secant of theta will be square root of 41 over 4, and our cotangent of theta is going to be 4 over -5. And recall that cosine is dealing with the x's now, the x and the radius, the x and the r. So in this particular case, in quadrant 4, we are dealing with the times when x is positive and y is negative. So anytime we have these functions like sine and cosecant, they're going to be negative because sine, or the y, is negative in quadrant 4. Cosine is going to be dealing with our x, and in this quadrant 4, the x is positive. So our values here are positive. And since tangent deals with y and x, well, if one of them's negative, the answer for those will both be negative.